aerification, our methods, and how we landed on this process. This is a 5/8 solid tine. This is what we use to drive the sand through the green into the profile. Now, by doing this method, like we talked about, we retain that bulk density, the faster recovery, and we get the deeper, cleaner channel that gives us more sand into the profile for a better dilution. We'll talk about that dilution process. These red jugs represent the organic matter, the thatch, the native soil, and the two methods of aerification. This one pulling a core, and this one our method of a solid tine. I'm going to show you our method and how that dilution works. So we could pull a core, the traditional method, which would remove 33% or 33 ounces. And then we replace that organic matter with our clean top dress sand. This gives us a dilution of 33%. Equally, we could do our method with the solid tine, in which we simply add 50 ounces or 50% more sand into the profile, and this is going to give us that exact same dilution, but retaining the bulk density, retaining the firmness for a quicker recover and better putting surface. That recovery is determined primarily by this soil temperature. We monitor this with a classic thermometer or some of the fancier devices we have. To determine when we can lower the height of cut, we look at what's in the basket. We look at this clipping yield, how much we're getting, and what percentage of it is sand. Now, this goes down to micro measurements, hundredths and thousandths of an inch. Getting down to that minute of a detail, we have to be certain that when we cut, we're not getting too much sand to dull the blade, to dull the bed knives, or to ruin any of our cutting machinery as we lower the height of cut, increase our speed, and get back to the putting surface that we want.